Okay, we're still working in 7.1, constructing proofs using these first four rules of implication or rules of inference. In the previous two lectures, I talked about just introduction to the material in 7.1, and in the second video, I talked about, or I constructed one proof, so make sure you look at those before you would look at this one. So now we're in exercise 7.1 part 3, and I'm looking at number 3. And if you recall from the previous video, what we're doing here is we're constructing a proof to derive that would show that you could derive this conclusion from these premises using these rules of implication. And the reason we can do this is because as long as you are using valid argument forms and you are using valid substitution instances, good substitution instances of those forms, you can keep using those argument forms to help you derive the conclusion from the premises, and it would show that this argument is valid, okay? So I was saying in the previous video that when you want to derive the conclusion from the premises, you want to, I actually need this here, that will make a big difference. This would be not L. When you want to derive the conclusion from the premises of an argument, you are going to use these. You want to identify the conclusion to some extent anyway in the premises. So the conclusion is not L, and you see that you have L, it's not negated, but you see you have L in this conditional, but this conditional is embedded in this disjunction. So the first thing you're going to need to do is break down the disjunction so you can even get to the conditional. And if you're reading along and understanding the rules that you have, you probably can readily see that if you could get a negated L because it's an antecedent, and if you can somehow do modus tollens with this here conditional and something else, you'll get that not L. So let's go ahead and see if we can let's break this down, and then hopefully I think we'll see pretty readily what we need to do. So if you want to break down a disjunction, you only have one rule right now. It's P wedge Q, not P will give us Q. So in this case, if P is K and B, then you need the negation of that, which would be not the case that K and B, and you have that in 2. So line 4, we can derive the entire right side of the disjunction, break down the disjunction and get the right side out, and that is by 1 and 2 disjunctive syllogism. If you don't understand that, make sure you pause and go back and look in the book and see why this is a valid substitution instance of the form disjunctive syllogism. Now remember, our goal is to get not L. We now have this conditional. The next thing will just help us break it down to get L. And we know by modus tollens that when we have the negation of the consequent of a conditional, we can break down that conditional and validly conclude with the negation of the antecedent. And you have the perfect setup for modus tollens right here. So by 3 and 4 and modus tollens, we get not L, which is our conclusion. So we're done. We've now constructed our proof. Okay, number 6, similar. You have not K here, and you see that you have K horseshoe L as part of this conditional. Now you know with modus ponens, that's a rule that will allow you to break down a conditional and get the consequent of that conditional out. So what do you need to do modus ponens in this case? You need whatever P is in that conditional, and in this case it's J. Now in this case you have J locked up in this disjunction, so your first thing is going to be to get J out, and then you can use it to do modus ponens. So you have, once again, disjunctive syllogism is the rule that will help you break down this. And you know that when you have the negation of the left side, you can pull out that right. So number 4 will be J by 2 and 3, disjunctive syllogism. Now we have that J we need, and we can do modus ponens. Now if this is P, and this is your main horseshoe, all of this is Q, okay? So 5 is going to be K horseshoe L by 1 and 4 and modus ponens. And now we need not K, so we're not done yet. We have K horseshoe L, and if we want the negation of that antecedent, we know by modus tollens we can get that, and we'll use, for line 6, 3 and 5 modus tollens, and that will give us not K. Now we have our conclusion, so we're finished. Okay, last one from the book. We have E horseshoe M, and you have only one rule that allows you to conclude with a conditional, and that would be this, right? Modus ponens and modus tollens allow you to break down a conditional, but the only rule you have here that allows you to conclude with a conditional is hypothetical syllogism. So what you need is E horseshoe some letter, and then that same letter, right? That would be your Q, horseshoe M, and that will, when you do hypothetical syllogism on that, that will give you E horseshoe M. And you see you have those, something like that, right? You have not F here is the common propositional statement, and then these are your E horseshoe M. But you can't do hypothetical syllogism on part of a statement. It only works when that horseshoe is the main operator. So the first thing you're going to have to do to get to these two conditionals is get them out of this conditional and this disjunction. So let's work on the first one. You have A horseshoe, E horseshoe, not F, and the antecedent is A. We know with modus ponens we can get the consequent out, and we do have A on this line. So line 5 will be 1 and 3 modus ponens, and that will give us E horseshoe, not F, okay? And now we just need to break down this line. We have a disjunction, and we have the negation of that disjunction on this line. So by, let's see, 2 and 4 disjunctive syllogism, we get not F horseshoe M. Now you broke down these two, and you have your conditionals by themselves on lines. They are the main operators. So now you have E horseshoe F, and not F, and then not F horseshoe M. So by hypothetical syllogism on 5 and 6, you get your conclusion. So now you're done. All right, now the last one I'm going to do, this was the last one in Apley. I don't know if it was exercise 4 or 5, but this one is a little bit tricky, but I thought we would do it on paper here, and I'll get it started, and then you can finish it on your own. So the first thing that you have to do is you want to identify your conclusion, and you have your conclusion P, and so you know that what you need to do is get out P out of that disjunction, okay? Now you have it in these two, so you're gonna, you're not sure, where is that going to come from. So the first thing you want to do is look at your single letter. Sometimes the nice thing to do is just to get started using what you have and breaking these down. So in this case, you're going to start by just doing modus ponens here because you maybe see that you have it. And if you do 3 and 4 modus ponens, that will give you not N wedge P, okay? And in fact, the reason to do that is because it will now allow you to do modus ponens to get not K out. We're going to use that to get not N out, and then you can use it to get your P. Now, another way I could have gone about it, I could have done 2 and 4 hypothetical syllogism, and then use not H that way. But I did the modus ponens. Okay, so you can either use that one or use 2 modus ponens. So now I have not N or P on a line by itself, and I have that same statement is the antecedent of this line here. So I'm going to do 2 and 5 and modus ponens again, and that will give me not K, okay? Now, what I need, okay, I have not N wedge P, and I'm trying to get P out. And of course we know we have disjunctive syllogism is the rule we're going to use there. Okay, and we know that when we have a letter and we have the negation, or when we have a statement and we have the negation of that statement, it will allow us to break down that wedge and get the right side out. So in our case, we want P out of here. So if not N wedge P, okay, not N is going to be, or P is going to be not N, and if P is not N, not P, of course, is going to be not N, right? That's your P there. Okay, so we're actually looking for not N. I know that's a little bit trickier than what we've done. That's why I'm going to help you along, and then you can just plug these into Applia and you'll finish it out. Okay, so the next thing that you need to do is going to be modus tollens will help you get that not N. So let me put your lines here, 1 and 6, and modus tollens, and then you have to fill in what you would get when you do modus tollens on 1 and 6, and then use that to break this line down and finish it out. So I've given you the first couple of lines for the Applia assignment, and then, like I said, you just have to finish it out, and when you get to the point where you break P down and you have P, you're finished. So give that one a try.